Hi, my name is Ben McCarthy, and today I'm going to be talking about a little thing that interests me quite a bit, and hopefully you guys like it. I'm going to be showing you a few tests, 7 actually, to identify minerals. Let me just start off by talking a little bit about minerals. All rocks are made up of different kinds of minerals. Right now, there are about 4,000 known minerals. And what is a mineral? So there are 5 actual scientific definitions for a mineral. They're kind of rules behind what can be classified as a mineral. So rule number 1 would be that all minerals must be solid. So you can have a solid mineral, and the second it melts, it's no longer a mineral. It has to be a solid. The second rule is that it must be naturally occurring. It can't be synthetic, man-made, anything like that. Rule number 3 is a pretty important one as well. It must be inorganic. So no plant-based, animal-based, nothing of the sort. It can't have derived from an animal. So an example of something that would be inorganic, like charcoal that comes from trees, so it's a no. Fossils, those also they come from dinosaurs. You can't use that. Rule number 4 is that they have to be homogeneous, which means that the chemical structure of it, the chemical composition, has to be pure and it has to be unique. This is very specific to minerals because they have to. That's a good way to identify minerals from one another. And then the last one is that the atomic structure of it has to be a unique pattern as well, because you can have minerals that have the same chemical composition, but the atomic structure is different. So it makes a different mineral. For an example would be graphite, which is what you use to write. It's in the lead of your pencils, and diamonds. They're both just carbon. One is just more tightly packed and it makes diamond, and the other one lets you write. Now that I gave you a brief intro to the minerals and that whole process, let me just talk about a few of the methods. There's the obvious ones, of course, like number 1 would be color. So you look at a mineral, and the majority of minerals are all similar colors, so it's not the best, but some of them are very unique in color. Like there's only one bright yellow one, which is sulfur. That's the only yellow mineral. So right away, if you see sulfur, you see a yellow one, you know it's that. But there are over 1,000 black ones. There's roughly around 400 white ones. There's, believe it or not, there's about 22 gold ones. So it's sometimes kind of tough to look at it just by the color. It's very rare that you'll be able to identify it right away, but you can try it. Another one would be streak. So this is the residue that a mineral would give off if you scratch it against a porcelain surface or something like that. If you grabbed, let's say, I'm just going to grab this gold one right here. This is pyrite. It's a clear example of how color can throw you off, because it looks like gold if you first look at it, but there are a few things that set it apart from it being gold. But if you were to scratch this against the porcelain surface, you would actually get a black streak from it, and that is something that geologists use to identify minerals quite often. It's usually a very good indicator right away. Another one is hardness, and it is defined as a mineral's ability to resist being scratched. So there are some minerals that are so soft that you could just scratch with your own nail. There are others that you can't scratch with your own nail, and they can actually scratch glass. Like this one, for example, that's amethyst. This one has the ability to cut glass. If I were to grab some glass and I could cut with it, and then it's the scale they use. It's called the Mohs hardness scale. It goes from 1 to 10, but it's not a scalar measurement. It's a very exponential one, because you have the softest mineral ever is a 1, and then the hardest one is a 10, and there's only one mineral in the world that is a 10, and that is diamond. It's by far the strongest or the hardest mineral out there. Then a few other common ways people do it is by looking at the specific gravity, and this means grabbing. Let's see, I had this one right here is malachite. It's a pretty cool looking one. If I had this amount of malachite in an equal volume of water, and I weighed the two, the amount of times that this weighs more than the water is its specific gravity. That's a really good scientific measurement for it that a lot of people use. A very unconventional one that only works a few times. Some other times it might get you killed, and I don't know if it's a very scientific one, is taste. There's one that's very common that a lot of people would know about. It's salt. That one, if you lick it, just right away you can tell it's salt. Magnetism is another. You just put it against metal, see if it attracts. Put it against a magnet, see if it is attracted. Luster is its ability to reflect light. Usually you describe metals as two different types of lusters. There's metallic and non-metallic. Looking at this right here, this is smoky quartz. This just looks like a piece of glass. Pyrite, on the other hand, looks like a metal. This one, you look at it and you can definitely tell it looks like metal. So this is a metallic mineral, and this is a non-metallic. And that's the 7 easy steps. There's another one where you could do a hydrochloric acid test and see if it reacts. That usually gives you a pretty good idea of what mineral you're dealing with if you have gone down the list of everything else. So it'd be color, streak, hardness, specific gravity, taste, if you dare, and magnetism and luster. So those are the ways you can identify them. I have actually quite a few more. There's this pyrite again. I'm going to show you this one right here would react very strongly with hydrochloric acid. It's called calcite, and it's a very, very strong reactor. Then there is this one right here, smoky quartz. Then this is another type of quartz, purple quartz. I have sodalite, which is kind of cool looking if you get a load of that. And this one right here. I just give you nice instructions on identifying minerals, and hopefully you can use them too.